Alright, so in this next part we'll start looking at the cotangent. Going to be very similar to tangent in what's going on here. So just a quick review for our tangent, how we got our tangent graphs was we started out just looking at our unit circle just so we could develop the graph. Looking at our unit circle, tangent's y over x. We're going to use the same idea for cotangent, where cotangent is x over y, and go through the same process that we did. We'll find some key points, and after we understand those key points and what our graph looks like, we were able to use the shape of the graph to just use our changes to get the rest of our graph. We'll look at the same things. We'll talk about what does cotangent start with, the same thing that we did with tangent. Tangent had a period length of pi because as we look at this graph, when we repeat itself, it repeats once we change over asymptotes. So when we look at cotangent then, our cotangent, and you can look at your unit circle. Cotangent is equal to x over y this time. So as we go through all our points, if we just look at our main key ones, if I start at 0, again our input is our radian, our output is our value of cotangent. And at 0 radians, I have an x value of 1, and I have a y value of 0. So when that happens, we saw that with our tangent, we are undefined. As I go to pi over 2 would be our next one that we would consider just as we develop this graph again, because we saw with tangent, and this will be very similar, we saw with tangent when I put all these points in, I either got 0 or undefined. So that didn't tell the whole story of the graph. We had to go look at some points in between. So again, very similar. When I go to pi over 2 and I look at x divided by the y value, my x value is 0, my y value is 1. So that would give me a value at pi over 2 of 0. As I go to pi, I'd have an x value of -1. I'd have a y value again of 0. That's undefined. And we see just kind of this alternating as I go to 3 pi over 2. We see this alternating zeros and undefined. So the development of this graph, as I put all my things in, and 2 pi would bring us back to undefined. So as I put these all in, I start out 0, I'm undefined. So I'm starting out with an asymptote on this one. And we'll write that down because that's going to be important. We start with an asymptote. And then I've got pi over 2. I've got 0. Pi, I've got an asymptote. 2 pi, I have another asymptote. And we just got zeros between all these. And same thing going the other way. So the setup looks the same. We've got asymptotes, we've got zeros halfway between the asymptotes. So we need a little more to the story, and we're wondering what happens between these points. What are good points to pick? For the same reasons as before, good points to pick would be pi over 4 and 3 pi over 4. Again, that's halfway between our all our quadrants. We'll look there. So if I look at pi over 4, and we look at this setup, so I'm going to go, what's that pi over 4? My point associated is square root of 2 over the square root of 2. And if I put that x over y, I just get 1. So very similar to our tangent graph. But at pi over 4, here I'm getting 1. Now if I go to this one would be 3 pi over 4 here. in the middle of the second quadrant. In the middle of the second quadrant, my point associated would be negative square root of 2 over 2, the square root of 2 over 2, and my x over y would give me negative 1. Now, asymptote behavior means that we're going to go to the infinity. It's going to act that way because that's how asymptotes act. Now, how does that look similar to, what's the difference between that and tangent? Tangent goes left to right. We are increasing in between our asymptotes. Cotangent, we are decreasing in between our asymptotes. So all these are going to be decreasing between here. You get the same action between all these asymptotes. And again, you're fine. You know the shape. This is what they should do. We can use that as an aid to graph. And that would just continue. So what's our period length? Our period length, if we just consider these two, if I trace this, I come from the asymptote, go through 1, 0, -1, and down to negative infinity. Then I hit my asymptote and I start again. So where my length of my period is coming from is between the asymptotes again. What's that length? My period would be pi. So tangent and cotangent have the same period length. That period length would be pi. And if I look at one more thing that we are going to note in yellow here, just like we said with tangent, tangent starts with 0. Here what we say is cotangent starts with an asymptote.